everyone. The following is a PPT for J component in signals and systems under the supervision of Mr. Loknath. Our topic is to find out power spectrum of square wave signal. The following are our group members: Zainul Uzair 15 BEC 623, Rayan Razi 16 BEC 0009, Arpan Roy 16 BEC 0295, and Prakar. Here is to find out power spectrum of square wave signal. For a given signal, the power spectrum gives a plot of the portion of a signal's power falling within given frequency bands. The most common way of generating a power spectrum is by using a discrete Fourier transform, but other techniques such as maximum entropy method can also be used. Generating square wave in MATLAB. Square T generates a square wave within the period 2 pi for the elements of a time vector t. It is similar to sine t, but unlike sine function, it creates a square wave within the peaks of +1 or -1 instead of a sine wave. It also generates a square wave with specified duty cycle, which is a number between 0 and 100. The duty cycle is the percent of the period in which the signal is positive. Fast Fourier transform. If x is a vector, then FFT of x returns the Fourier transform of the vector. If x is a matrix, then FFT of x treats the columns of x as vectors and returns the Fourier transform of each column. If x is multidimensional array, then FFT of x treats the values along the first array dimension whose size does not equal to 1 as vectors and returns the Fourier transform of each vector. How is power spectrum formed? Mx is equals to absolute value of x. To find the absolute value of Fourier transform for power spectrum, this is done as Fourier spectrum can be positive, negative, or 0, but a power spectrum has to be positive. We finally plot mx versus f graph, where f is the frequency to obtain power spectrum. Here's the variable description. We will be switching to the MATLAB code. Is the MATLAB code. Firstly, we shall explain functions used in this code to generate power spectrum of square wave. As the name suggests, a square function is used to form a square wave of period 2 pi. FFT has been used to find fast Fourier transform of x with nfft as the length of this function. Figure. This function is used to open a new window to plot a graph. Plotting is done using the plot function where t is the horizontal axis and x is the function of t or vertical axis. Ylim and xlim provides the boundary positions, that is -1.2 to 3 for vertical and 0 to 10 for horizontal axis. Xlabel and ylabel puts the axis name, and title, as the name suggests, allocates the title to figure 1. Now you will see the result of what we have done till now. This is our input signal. We need to find Fourier transform, but before that, let me explain a very important function. Stem function that plots data sequence x at values specified by f. The f and x inputs must be matrices of same size. If both f and x are vectors, then stem plots entries in x against corresponding entries in app. Hold on, keyword that retains graph. So, the Fourier transform will be as. Hence, our final output, the power spectrum, is